Greetings to everyone. Welcome back. Now we are going to study about polymers. So, in polymers, we are going to study about introduction to polymer, types of polymers, classification, characteristics, and their applications. Coming to the introduction, poly, poly mean polymers are very large molecules made when hundreds of monomers join together to form one chain. So the word polymer comes from the Greek word that is poly means many and mer means parts. So many parts combine together to form a polymer. Right. So it is coming from monomer, that is single unit. So all single units combine together to form a polymer. So polymer is used as a synonym for plastic. Okay? So all plastics are polymers, but all polymers are not plastics. Example, polyethylene. Now, coming to the types of polymers, that is natural polymers, homopolymer, copolymer, thermoplastics, thermosets, and long chain polymers. So, natural polymers. So, you can give me an example of a natural polymer, that is cotton, then wool, DNA, RNA, etc. All these are natural polymers, that is, they are found in nature itself. Then homopolymers. Homopolymers are synthesized from a single type of monomer. Okay? So homopolymers consist of chains with identical bonding linkages to each monomer unit. Copolymer. That is, when two different monomers combine together to form a polymer, that is called as a copolymer. Okay? Then thermoplastic. Type of plastics that can be softened by heating and hardened by cooling and is called as thermoplastic material. So they are not cross-linked polymers. Examples: polyethylene, nylon, polyvinyl chloride. Then thermosets. Thermosets have the property of becoming permanently hard and rigid when heated. So thermosets are hard and rigid at room temperature and do not soften on heating. Example: epoxy resins, phenolic resins, unsaturated polyester resins. And coming to the last one, that is long chain polymers, a very long strand of repeating molecules linked together by primary bond. The polymer chains can orient themselves in lines as they enter a mold and can be annealed, and so they can recoil. Coming to the classification of polymer, so based on the origin of source, they are classified into natural, semi-synthetic, synthetic. Based on structure, linear, branched, cross-linked. Then based on molecular forces, elastomers, fibers, thermoplastics, thermosets, and then based on polymerization, mode of polymerization, that is addition and condensation. So based on origin of source, already we have discussed, that is natural, synthetic, and semi-synthetic. So natural polymer example: synthetic polymer, polyethylene, nylon, terling, semi-synthetic rayon. Then based on structure, linear, branched, and cross-linked polymers. Then we have based on mode of polymerization, we have additional and condensation. So additional polymerization, same kind of monomers. It is rapid chain reaction, so it is also called as chain polymerization. Each reaction sets up the condition for another to proceed. Okay? So that is initiation, propagation, and termination. Whereas in condensation polymerization, it involves a polymerization reaction between two monomers with the expulsion of single byproduct. Like, that is byproducts like water, HCl, methanol. Ethanol can be obtained as a byproduct. So it involves individual chemical reaction between chemical reactive byproduct is formed and condensed out. Okay? So that is why this is also called as step growth polymerization. It is slower and meets reactive functional groups. Then, based on molecular forces, it is classified into elastomers, fibrous, thermoplastic, and thermoset polymers. So, elastomers, rubber-like solids, weak interactive interaction forces are present. Example, rubber. Then, fibers, strong, tough, high tensile strength, and strong forces of interaction are present. Example, nylon 6. Then thermoplastics, they have intermediate forces of attraction. Example, PVC, polyvinyl chloride. Thermosetting, these polymers greatly improve the material's mechanical properties. So it provides enhanced chemical and heat resistance. Example, phenolics, epoxies, and silicon. Then depending on tacticity, that is arrangement of functional groups in a polymer, it is classified as isotactic, symbiotic, and atactic. The isotactic polymers are if the functional groups are arranged on the same side, and if the functional groups are arranged alternatively, they are called as symbiotic. And if they are arranged in a random manner, it is called as atactic polymers. Okay. Then coming to the differences between thermoplastic and thermosets. So thermoplastic can be synthesized by the process of called addition polymerization, whereas thermosets are formed by condensation polymerization. So that is byproduct is condensed. Then thermoplastic is processed by injection molding, extrusion process, blow molding, thermoforming processes, etc. So thermosetting for plastic is processed by compression molding and reaction injection molding. Then these are secondary bonds between molecular chains. These are primary bonds between molecular chains held together by strong cross-links. So that means these are linear and these are cross-linked. Then these have low melting points and low tensile strength, whereas these have high melting points and high tensile strength. Then thermoplastic is lower in molecular weight compared to thermosetting plastic, whereas thermoset plastic is high in molecular. Then examples, polystyrene, Teflon, acrylic, nylon, thermosetting, vulcanized rubber, bakelite, polyurethane, epoxy resin, vinyl ester resin. Then these are some of the thermosetting plastic materials. So if I show you with the diagram, then you can realize what we are using, right? So this is formica, melamine of formaldehyde, and this is bakelite. Then we have urea formaldehyde and then epoxy resins used as adhesives. Then polyethylene, then polypropylene, okay, as files. Then we have polystyrene and then nylon. So this is all about the introduction of polymers. So depending upon the monomers, homomer and heteropolymer, copolymer. Example we have here homopolymer, polyethylene, heteropolymer, adipic acid and hexamethylene diamine react to form nylon 6,6. Then we have phenol and formaldehyde forming bakelite. So these are the two examples for the condensation polymerization, whereas this is the example of addition polymerization. Right? Here single monomer is used and here different monomers are used. So these are the functional groups, that is depending upon the functional groups attached, it is staticity. And then depending upon the n number of units, that is always we write here n. So what is this n? N is nothing but depending upon this n, it is classified into two types again, that is oligopolymers and high polymers. So if it is, n is greater than 600, then it is called as high polymers. If n is less than 600, then it is called as oligopolymers. So oligo and high polymers are depending upon this level. So this is about the classification types, and then properties of polymers. Thank you.